Hello, this is a video on determining a net ionic reaction from a complete chemical reaction, and it's usually going to be a balanced complete chemical reaction. This video, or the determining of net ionic reactions, can occur for any of the 5 major types of chemical reaction. Remember, it's synthesis, decomposition, single replacement, double replacement, and combustion. However, the main use of net ionic reactions is single and double replacement reactions. So I will talk about double net ionic reactions for the other ones in a different video. So a net ionic reaction, how are they different? The complete chemical reaction shows all species, even the species that are simply watching and not changing in the chemical reaction. Kind of like, since the Patriots are going to the Super Bowl, or playing in the Super Bowl this weekend. I believe it's Super Bowl 49. It's like the Super Bowl, seeing both the players and all the fans, the spectators. Only the players are playing, changing. All the spectators are simply watching. That, in talking about everybody at the Super Bowl, would be an indication or an analogy of the complete chemical reaction. If you just want to see what the players are doing, the things that are changing, then that's what a net ionic reaction is. It will remove all the substances that just are watching and are only going to show you species that are changing in the chemical reaction. So the first thing you do, like the step says, you need a balanced chemical reaction, complete chemical reaction, which you see here. It's a single replacement reaction. Then what you do in the second step is you simply take all the aqueous substances and break them up into their ion. And all the other substances you just rewrite. So the first one is calcium, which is solid, so it's not, so you can simply rewrite it. You don't have to put the zeros in. They'll be used in a later thing, or you can. Every element's charge, so to speak, is 0. Plus, now silver nitrate is made up of, since it's aqueous, there is no silver nitrate in a solution of silver nitrate. It's made up of ions, silver ions, Ag1 plus. And again, I apologize. Hopefully by the time you see this, I'll have changed it from +1 to 1 plus, because charges are supposed to have the signs on the other side, after the numbers, not before the numbers. So it's silver 1 plus and nitrate 1 minus. And as you can see, since there is only one silver ion in the compound, but there's two of them, it's 2Ag1 plus. And again, you want 2NO3 1 minus. To give you this calcium nitrate will break up, and you have 1Ca2 plus 2NO3 1 minus, plus the silver. Silver is an element. It's a solid. It doesn't change. So you just rewrite it 2Ag0 solid. Now what happens is, if you make pretend that the arrow is an equal sign, you see that the nitrates haven't changed at all. So you put a line through them, okay, and each side of any substance that is the same on one side or the other. Now, there can never be a 3 or a 2. These numbers all must be the same, since you're using a balanced chemical reaction. So you would cancel these out, put a line through, which means they're not participating in the chemical reaction. And we have a name for them. They're called spectator ions. So therefore, they're spectator ions. So what you're going to do then is you're going to then rewrite everything except the spectator ions. So 1 calcium solid plus 2 Ag1 plus to give me 1 calcium 2 plus 2 Ag0 Ag solid. which is the net ionic reaction, and it shows you just the species that are changing. Now, for this chemical reaction, just to give you a little more chemistry, what this really says is that the elemental calcium is releasing 2 electrons to form the calcium ion, while the silver ions is taking in 1 electron to form the silver solid. That's why you need 2 of them. Okay? And that's how you do all net ionic reactions. And again, sometimes what happens with determining the net ionic reaction from the complete chemical reaction, there's actually no change. The only thing you're doing is expanding the aqueous chemical formulas into their ions, because every species in the chemical reaction is changing. So therefore, there are no spectator ions. And that happens in several of the different types of chemical reaction. But we'll talk about that in a different video. Thank you.